Hello and welcome. Today we're continuing with part 2, where we're looking at how to assign R and S configuration to a stereocenter. Remember, a stereocenter in this case is a carbon that has 4 different groups. So if you focus on this carbon here, that is one group, 2, 3, and 4 different groups connected to that carbon. Therefore, it's a stereocenter. Now, in order to assign R and S configuration, we need to follow what's called Kern-Ingold pre-log system, where number 1, we're going to prioritize them in such a way that a higher molecular group or atom has higher priority. So in this case, oxygen has a mass of 16, nitrogen has a mass of 14, and that one there is a carbon with a mass of 12, and that's a hydrogen with a mass of 1. So you can clearly see that oxygen is heavier, and therefore that's going to be priority number 1, followed by nitrogen, so that will be priority number 2, and then carbon, so that will be priority number 3, and hydrogen will be priority number 4. Step number 2, rotate the molecule in such a way that the atom or the group with the lowest priority, that's priority number 4, is going away from you. So in this case, this hydrogen has these hashed or dashed lines, and therefore that means it's going away, so that already has the right orientation. We will see another example soon where the group number 4 is not going away and how to handle that case. So in this case, this is just straightforward. Number 4 is already away, and then now number 3, just focus on priority number 1, 2, and 3. If it increases in the clockwise direction, we call that R stereocenter. But if it's counterclockwise, so 1, 2, 3, so it increases in the reverse direction, then that is S configuration. Now let's look at this. Number 1 is here, and then number 2 is on the left, so that's 2, and then 3. So if you just focus on number 1, 2, and 3, you'll see that it increases like this, 1, 2, and then 3. So that looks like that, which is basically this one here. And therefore, that center is R configuration. Now, let's look at the second case where the group number 4, high priority number 4, is not going away. And just from the previous example, we saw that the highest priority will be oxygen. So that will be priority number 1. And then nitrogen with a mass of 14 will be priority number 2. And then carbon with a mass of 12, priority number 3. And hydrogen with a mass of 1 will be priority number 4. So we've finished the prioritization. Next, we rotate the molecule in such a way that number 4 is going away, but as you can see, number 4 is coming out. So that does not work. So that means we cannot assign this a stereocenter to this structure. So what we need to do is to rotate. Now let me quickly redraw this structure. You have it look like that. You have number 2 here, number 3, and then going in, you have number 1, and then coming out, you have number 4, that one there. So according to rule number 2, we need to arrange in such a way that this number 4 goes away. So in other words, we need to switch these 2 places. So we're going to say switch number 1 and number 4. So we still have number 2 there. Number 3 is still there. But now we're switching number 1 and number 4, and therefore number 4 is going away while number 1 is coming out. And that now has the right orientation, so that number 4 now is away. And then now you just focus on number 1, 2, and 3, and you'll see that it increases like that. So that's clockwise. And because that's clockwise, then that center there is R configuration. But remember that we arrived at R configuration after switching. That means if we work backwards, then this center is actually S, and this center is the same as that one, therefore that one is S configuration. Thank you very much for watching. If you enjoyed this presentation, please like this video and also support the channel by subscribing.